Bismillahirrahmanirrahim. Assalamu alaikum. This is me, Tavinda Mujib, a student of MSc final year from the Department of Inorganic Chemistry. Here to be present my topic, analysis of commercial sodium carbonate. But first of all, I would like to thank my most respected and hard-working teachers, to Dr. Noshaba Rafiq, Dr. Kuratul Ang, and Dr. Sayyida Rehana Zia. Now I am going to tell about some commercial sodium carbonate. Sodium carbonate is commonly known as washing soda, sal soda, and its straight name is soda ash. It is a white anhydrous powder-like material. It is an essential raw material used in the manufacturing of glass, detergents, chemicals, and other industrial products. Uses of sodium carbonate. As I told you before, that it is an natural raw material used in the manufacturing of glass, chemicals, detergents, and soap. It is also used in other industrial processes and products like mining and water treatment. These are the average volumes of soda ash in these products is as follows: glass 50%, chemical 26%, soap and detergents 10%, miscellaneous uses 4%, blue gas diesel fluorization 2%, pulp and paper 2%. Now I'm going to tell about analysis of commercial sodium carbonate. Commercial sodium carbonate always contains the impurity of sodium bicarbonate. This analysis is based on volumetric and titrimetric analysis, which involves acid-base reaction and neutralization reaction. This analysis consists on two major steps. First is standardization of HCl and the other is analysis of commercial sodium carbonate. First step, a fixed volume of sample solution is titrated against standard HCl solution using phenolphthalein indicator to find out the volume of standard HCl solution consumed to neutralize sodium carbonate into sodium bicarbonate and sodium chloride. Now in the second step, a fixed volume of sample solution is titrated against standard HCl solution using methyl orange as an indicator to find out the volume of standard HCl solution consumed to neutralize impurity of sodium bicarbonate. The subtraction of twice volume of standard HCl solution obtained in first step from the volume of HCl solution consumed in second step corresponds the volume of standard HCl solution consumed against impurity of sodium bicarbonate. Now, these are the chemical and reagents which are used in this analysis. The pure anhydrous sodium carbonate in solid state, HCl 37% solution, commercial sodium carbonate in solid state, phenolphthalein indicator solution, and methyl orange solution used as an indicator. Now procedure, standardization of HCl solution. Dry anhydrous pure sodium carbonate in oven 160 at 160 centigrade for half an hour, then cool in desiccator up to room temperature. After calculation, the weight of by applying formula of weight calculation, accurately weighed Anhydrous pure sodium carbonate up to 4 decimals, that is 1.5079, while transfer to 250 ml volumetric flask to prepare its 0.1 molar standard solution. Make the volume of solution up to the mark with distilled water. Now in the third step, calculate the molarity of stock concentrated HCl solution using its percentage and specific gravity as given on the bottom. Now in the fourth step, calculate the volume of stock concentrated HCl solution to prepare its 0.1 molar HCl solution in a beaker. Rinse and fill the burette with prepared HCl solution and note the initial burette reading. Titration: transfer 10 ml of standard sodium carbonate solution to conical flask. Add some water and 1 or 2 drops of naphthalene indicator and titrate it against HCl solution until concordant reading not obtained. Analysis of sample of commercial sodium carbonate. Weigh accurately 1.5 to 1.6 gram of sample solution in a vial. Transfer to 250 ml volumetric flask. Make the volume up to the mark with distilled water. Now for the titration, transfer 10 ml of sample solution of commercial sodium carbonate to conical flask and add some water and 1 or 2 drops of naphthalene indicator and titrate it against standard HCl solution until pink color turns colorless. Note the burette reading until concordant reading not obtained. Now for the second titration, transfer 10 ml of sample solution to a conical flask, add some water and 1 or 2 drops of methyl orange indicator and titrate it against standard HCl solution until yellow solution turns into orange. Note the burette reading until concordant reading not obtained. Now come to the chemical equations. Standardization of HCl solution using naphthalene indicator. Sodium carbonate reacts with HCl to form sodium bicarbonate and sodium chloride. By using methyl orange indicator, sodium carbonate reacts with 2 mole of HCl to form 2 moles of sodium chloride plus water molecule and carbon dioxide. Reaction of sodium carbonate with HCl in the presence of naphthalene indicator. Sodium carbonate reacts with HCl to form sodium bicarbonate plus sodium chloride, and reaction of sodium carbonate with HCl in the presence of methyl orange indicator. Sodium carbonate reacts with 2 mole of HCl and 2 moles of sodium chloride, H2O, and carbon dioxide. Reaction of sodium bicarbonate with HCl in the presence of methyl orange indicator. Sodium carbonate plus HCl to form sodium chloride, water molecule, and carbon dioxide. Now the net equations. Sodium bicarbonate reacts with sodium carbonate and HCl to form 3 moles of sodium chloride and 2 moles of water molecule and 2 moles of carbon dioxide. Now come to the observation. Journal observation. These are the journal observation. The weight of pure anhydrous sodium carbonate obtains 1.5079 gram per 250 ml. Percentage of stock concentrated HCl solution is 37%. Specific gravity of stock concentrated HCl solution is 1.18 gram per ml, and these are the molar masses of these chemicals. Now standardization of SCl solution. In this we obtain the reading 9.4 ml of standard sodium carbonate solution for the standardization of SCl solution. Now before the titration, the flask solution color is pink, and after the titration its endpoint is colorless. Now for the analysis of sample, determination of volume of standard HCl solution consumed against sodium carbonate only present in sample solution. In the first titration, obtain the reading 5.6 ml. And now for the second titration, we obtain the reading 11.3, and its color is, before the titration the solution is of yellow color, and after the titration it's turned into orange. Now comes to the calculations. Determination of weight of pure anhydrous sodium carbonate to prepare is 0.1 molar standard solution by using the formula of weight, that is molarity multiplied by molar mass multiplied by volume divided by 1000. And now put in the formula the values, we get 2.6498 gram. For the calculation of molarity of standard sodium carbonate, apply the formula weight multiplied by 1000 divided by molar mass multiplied by volume, and we get 0.0962 molar concentration. Determination of concentration of stock concentrated HCl solution by using volume relationship, that is 100 ml stock concentrated HCl solution contains 37 ml HCl. Now using the formula of specific gravity, that is equals to mass per volume, and we get the number of moles of HCl is equals to 1.19 mole. By applying unitary method, we get the molar concentration of HCl, that is 12 molar. Now from the method 2, the formula is used. Molarity of stock concentrated HCl solution is equals to percentage multiplied by specific gravity multiplied by 10 divided by molar mass, and we get the concentration of stock concentrated HCl solution, that is 12 molar. Determination of volume of stock concentrated HCl solution to prepare is about 0.1 molar solution. By applying the formula of dilution factor, we get the volume, that is approximately 4.2 ml. For the standardization of HCl solution, we use the unitary method and mole ratio method to calculate the number of moles of HCl. So here we use the mole ratio in the presence of phenolphthalein, that is 1 sodium carbonate is equals to 1 HCl. 1 mole of HCl, we obtain the moles of HCl, that is 0.0985 moles. For the analysis of commercial sodium carbonate, determination of % purity of commercial sodium carbonate, determination of number of moles of sodium carbonate present in 250 ml sample solution. By applying unitary method, we get 5.5160 exponent minus 4 mole of HCl. Apply mole ratio method, 1 sodium carbonate is equals to 1 mole of HCl. We get the mole of sodium carbonate, that is 5.516 exponent minus 4. Now we apply here back calculation of unitary method. We get the mole of sodium carbonate into 50 ml sample solution, that is 0.0138 moles. Determination of weight of sodium carbonate present in 250 ml sample solution using the formula of weight, that is number of moles multiplied by molar mass, and we get the weight of of sodium carbonate into 50 ml sample solution, that is 1.4627 gram. Now use the formula of percent purity, that is weight of sodium carbonate divided by weight of sample of commercial sodium carbonate, multiply by 100, and we get the percentage, that is 94.83%. Commercial sodium carbonate. Now the determination of volume of standard HCl solution consumed against sodium bicarbonate impurity present in sample solution. Volume of standard HCl solution consumed against sodium bicarbonate impurity present in sample solution is equals to total volume of standard HCl solution consumed against sodium carbonate and sodium bicarbonate using methyl orange. Subtraction the 2 times of the volume of standard HCl solution consumed against sodium carbonate using phenolphthalein indicator. Purity we get 0.1 ml. Determination of number of mole of sodium bicarbonate impurity present into 50 ml sample solution by using unitary method and mole ratio method, we obtain 2.4625 exponent minus 4 mole of sodium bicarbonate. Now apply the formula of weight, we obtain 0.0206 gram per 250 ml of sodium bicarbonate. For the percent impurity, apply the formula of percent impurity, weight of sodium bicarbonate divided by weight of sample of commercial sodium carbonate, multiply by 100, we obtain 1.33% of sodium bicarbonate. Now comes to the result, we obtain the percent purity of the given sample of commercial sodium carbonate is found to be 94.88%. The percent impurity of sodium bicarbonate in the given sample of commercial sodium carbonate is found to be 1.33%. Thank you.